Okay, so now we are talking about reflections on a coordinate plane and their corresponding algebraic descriptions. Algebraic descriptions. So first we're going to start off with reflecting across the x-axis. So that's just, again, let's label this, I guess. I'll label this one x. Put the wrong color. That color. That one. This one is the x-axis, and this one is the y-axis. And we're going to reflect across the x-axis. We're just going to reflect one point. If you have multiple points that are joined together with a line segment, you'll have yourself if it lines is more than 2 points, 3 or more, you'll have yourself a polygon, as long as they're straight line segments. And this principle will reflect that entire line segment and or those the polygon in similar fashion. So what we have here, this what a a line of reflection really is a midpoint for all of those points, and it just reflects those points across 90 degrees each point from that midpoint. And since this is a reflection across the x-axis, the 90-degree point would be parallel with the y-axis. So we're not going to have any change in distance from the y-axis as this reflects across the x-axis. Right, so a reflection across the x-axis, all we're really going to have is a change in the y value, and it's just going to flop its sign. The absolute value of y will stay the same, but the sign will change. Everything about x is going to stay the same because we're not actually changing any distance away from the y. So that looks like this, right? So we're going to be going from here, right? And it's going to be this is well, probably should label this first. It's the x-axis. The x value is change this to blue first. The x value of this is 5. No, it's not. It's 3. And then the y value is 1, 2, 3, 4, 5. So this point is 3, 5. Okay, so as we approach this with let me do polka dots, that doesn't right. So this thing is going to approach the midpoint, which is the axis, and now it's 0, 5, but it's going to change. No, it's not. It's 3, 0. I'm sorry, it's late. This is now 3, 0, right? But now it's going to start reflecting back the other way. It's maintaining 3, and now it's back to 5. So 1, 2, 3, 4, 5, and now it is reflected back to 5. So get the point for it. Oh, that's driving me crazy. It's got to be straight. Okay. Okay, now that's the point for it, and we'll make a nice, not so round point. The other one was, I don't have time for that. All right, and now this is negative, well, now this is 3 still. It's the same distance from here and still positive, right? And it's negative 5. It has the same absolute value from the x-axis. It does it 1, 2, 3, 4, 5, but it is negative in value, right? Which is why this equation is the way it is. This algebraic description is the way it is. It's a reflection across the x-axis. Okay, now if we reflect across the y-axis, it's similar, but opposite. You can't see that red at all, can you? We're just not going to do that. All right, so we're reflecting across the x-axis. Let's reflect this 3, 5 across the x-axis, right? So if we do that, we're gonna reflect it. I'll use the point button again. So we're gonna reflect it. You can notice that this is now 0, 5, right? It's the 3 is changing, but the 5 hasn't changed, right? But now it's back to 3. Now it's negative 3, 5, right? And our negative 3, 5, the absolute value of 3 is the same. It's still 3 from our midpoint line, which is our y-axis, right? But the sign has changed. But 5 is still 5. It hasn't changed its distance from x at all, right? So this is why this reflection across the y-axis is what it is, right? It's negative x minus y. It's negative. It's the x turned into negative x. And instead of negative x minus y, our negative x comma y, our x changed to negative x, and but our 5 stayed the same. Over here, our x stayed the same, but our y changed into negative y. That's all that's saying is what changed. Okay. So now let's do a whole bunch of stuff here. Go back a little bit. Straight shot of that, but I didn't. Oh well. Now let's go back and make with that dot, maybe a few other dots. Make a triangle, I guess. First we need to draw a line. So let's say we have a slope. We have a line that has a value of -1. Like as x changes by 1, the y will change by 1. Kind of like this. Okay, this is that actually -1. Sorry, this is this one. The reflection across the axis, across the line, x equals -y. Or you can say negative x equals y, or y equals -x, or negative y equals x. It doesn't matter which way you read it, but it is a negative slope of 1-to-1 ratio. It has every 1 change in x, there's a change in y, or every 1 change in y, there's a change in x in the negative direction. So if it was positive, it would look like that, right? But it's not negative, right? So let's plot some points here and make a polygon. I'll do one like right here, I guess. Like at there, and then we'll do one like over here, I guess. Right there. See, triangle. It's not a straight line. Make this into a triangle like this. Okay, and I'll delete this. Right click off. Not like that though. And we'll name this A, B, and C. This is triangle A, B, C. And you might see a question that says, hey, reflect ABC across, why am I doing C so thick? Reflect ABC across the line x negative y, or negative xy, or y equals, negative x, so this is how you approach that problem. Similar to what we did in other ones. You make a little table, A, B, C, and you say what is your x and what is your y, And then you split that up. And then whatever your A, B, C reflection is going to be. And then you have to, well, we're going to say that it's going to be, I'll make it red. Red is going to show up. We're going to make it red. Red. And red shows up pretty good. And so our change in X, our change in Y is going to be a reflection across the X-axis. The X and the Y flop spots, and they flop signs. And I'm just going to name this thing A prime, B prime, and C prime. Okay, so let's go ahead and pull off the coordinate planes for this. So I'm going to go ahead and say this one's kind of in between. So, but I'm going to go ahead and say that this one is attached to this point. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My Y value is 10. My X value is negative 1, 2, 3, 4, 5. It's 5 in the negative direction. Okay, my B value is negative 10, 11, 12. Yeah, we'll say that's 12. Y direction, 12. And 1, 2, 3, 4, 5, 6, 7. I'll say that's 7 up, or 7 positive direction over. And then C is 1, 2, 3 over. And 1, 2, 3, 4, 5 up. Close enough. Okay, so now let's transpose and do all of our magic here. Our X's becomes our Y's, and it's going to turn the sign. So this is going to become negative a negative, so it's going to become a turn sign. This has to be red. Negative of the negative is going to become positive, so it's going to become 5. Right. 7 is going to become negative 7. My 3 is going to become negative 3. Over here, these become my X's, so it's going to become negative 10 because it says negative Y. It's going to be negative 12. This one's going to become negative 5. So let's plot these points here. So 10, negative 10, comma 5. So that's going to be point A, negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 1, 2, 3, 4, 5. So about right there. Close is my A prime. Let's do B prime. Hope I got enough room on the board for this thing. Okay, so B prime is negative 12. It's going to be right at the cusp. It's negative 12. Negative 7. 1, 2, 3, 4, 5, 6, 7. Straight over. It's going to be like right here ish. It's going to be B prime. And then C prime is going to be negative 5. 1, 2, 3, 4, 5. And then ish. Okay, so I'll connect the dots after I label that. C prime, C prime, C prime, and I'll label it, and I'll connect the dots. So that's my A, C. This is my A, B. This is my B to C. Now you can see that it's reflected across the the line x equals negative y. So that is how you do a reflection across a line. Just remember these four relationships, and you'll be all right. Hope that helped. Have a good night. I'm calling it one.